Hello students, in this lecture session we shall discuss some important 1 mark very short answer type question from physics 1 that frequently appear in Makaut semester exam. Although these questions carry only 1 mark, they are conceptually important because they form the foundation of many longer numerical and theoretical problems. I am Dr. Saurabh Ball from the Department of Physics, Swami Vivekananda Institute of Science and Technology. Let us begin with the first question. What is the displacement of a particle executing simple harmonic motion when the velocity is maximum? The answer is 0. To understand this, let us recall the nature of simple harmonic motion. In simple harmonic motion, let's dive into this example of a pendulum. A particle or a bob oscillates about a mean position. At the extreme position, the displacement is maximum, but the velocity becomes 0 because the particle momentarily changes its direction of motion. As the particle moves towards the mean position, its speed continuously increases and the restoring force acting on the particle becomes 0 at the mean position because the displacement is 0 there. Consequently, the particle attains its maximum velocity at this point. Therefore, the velocity of a particle executing simple harmonic motion is maximum. Its displacement must be 0. This is a very important characteristics of SHM and is frequently tested in examinations. Question number 2, what is population inversion? So population inversion is the condition in which the number of atoms or molecules in an excited state becomes greater than the number in the lower energy state or ground state. This is essential for a laser action. Normally, according to thermal equilibrium, most atoms remain in the ground state and only a few occupy higher energy level. Therefore, achieving population inversion requires a special mechanism where the metastable state comes into play. So what's a metastable state? Metastable state, it is concerned with an excited energy level where atoms can remain for relatively longer time, typically 10 raised to minus 3 seconds or longer, between 10 raised to 3 to 10 raised to 6, compared with ordinary excited state that have lifetime of about 10 raised to minus 8 seconds. So when the excited state is in the metastable state, automatically, so by the process of absorption, the atoms get absorbed to the excited level, and if the excited level is in the metastable state, it stays it for the longer time, and then the population in the excited state becomes greater. And then these atoms or molecules can come down to the ground state by the process of stimulated emission. Moving to the next question, what is the difference between a polar dielectric and a non-polar dielectric? The answer is that a polar dielectric possesses a permanent dipole moment, while whereas the non-polar dielectric does not possess a permanent dipole moment or no dipole moment. So a dipole moment arises when the center of positive and negative charge do not coincide, or we can say it's separated by a distance. In polar molecules such as water or hydrogen chloride, the charge distribution is naturally asymmetric, giving rise to a permanent dipole moment even in the absence of an external field. In contrast, the nonpolar molecules such as oxygen and nitrogen or methane, carbon dioxide, have symmetrical charge distribution. As a result, their net dipole moment is 0 under normal condition. So when an external electric field is applied, polar dielectrics align their existing dipoles with the field, and non-polar dielectrics, on the other hand, develop induced dipoles due to distortion of their electron clouds. Moving to question number 4. Phase velocity and group velocity are equal when the medium is dash. Phase velocity is the speed which an individual wave crest travels, whereas group velocity is the speed with which the overall wave packet or energy propagates. So in this case, the answer is non-dispersive medium. So we can explain this from this relation between group velocity and phase velocity. So Vg represents the group velocity and Vp represents the phase velocity. From this equation, for non-dispersive medium, dVp by d lambda is 0. So mathematically or numerically, we can say the phase velocity and the group velocity, they are equal. Question number 5. The question says, Maxwell's-Boltzmann statistics, in short MB statistics, is applicable for photons. Is the statement true or false? So the answer is false. Photons are bosons, meaning they have integral spin, and bosons obey Bose-Einstein statistics. Maxwell's-Boltzmann statistics apply mainly to classical particles where quantum effects can be neglected. Example includes molecules of an ideal gas at ordinary temperature and pressure. Since photons are quantum particles and do not obey Pauli's exclusion principle, they follow Bose-Einstein statistics rather than Maxwell's-Boltzmann statistics. Moving to question number 6, the question says, define solenoidal vector. So solenoidal vector is a vector field whose divergence is 0. Mathematically, we can say that the vector field satisfies the condition of divergence of A equals 0, that is a solenoidal vector. So physically, a solenoidal vector has no sources or sinks within the region under consideration. So the field lines neither originate or terminate inside the region. A classical example in this case, in the magnetic field, or you can say for a solenoidal field, current carrying solenoid, where the lines are parallel inside the solenoidal field, so divergence of the magnetic field is 0. Now, what is the optic axis of a crystal? That's question number 7. So the optic axis of a crystal is the direction along which the light propagates without experiencing double refraction. So many crystals are anisotropic, meaning their optical properties vary with direction. So when light enters a crystal, it generally splits into two refracted rays known as the ordinary and the extraordinary rays. However, if light travels along a specific direction called the optic axis, both rays travel with the same velocity and no splitting occurs. Thus, double refraction disappears along the optic axis. Question number 8, define magnetization vector. So the magnetization vector is defined as the net magnetic dipole moment per unit volume of a magnetic material. So when a magnetic material is placed in an external magnetic field, many magnetic dipoles tend to align in the direction of the field, like this in the figure. So a large value of M indicates a stronger magnetic response. So in this case, we can express in the form of a equation or mathematical expression. The magnetization is the sum of the magnetic dipole moment divided by the volume. Question number 9. What is the 0-point energy of a quantum harmonic oscillator? So the 0 point energy is the minimum, the lowest possible energy by a quantum harmonic oscillator at absolute zero temperature. In classical mechanics, a particle at absolute zero would have zero kinetic and potential energy. However, quantum mechanics predicts a different result due to, you can say, Heisenberg's uncertainty principle. So a particle cannot simultaneously have precisely defined position and momentum. Therefore, the oscillator can never be completely at rest. So even in the lowest energy state, it retains a finite amount of energy known as the 0 point energy. And you can say that the formula is half h cut omega. H cut is h by 2 pi, where h is the Planck's constant. Now, question number 10. Which statistical distribution is followed by free electron in a conductor? Now, electrons are fermions with half integral spin and obey Pauli's exclusion principle. So, which means that no electrons can occupy the same quantum state simultaneously. Because of this restriction, the electrons follow Fermi-Dirac statistics. Moving into question number 11, which property of light exhibits its transverse nature? Polarization refers to the restriction of vibration of a wave into a particular direction. So only transverse wave can exhibit polarization, and vibrations occur perpendicular to the direction of the propagation. Longitudinal waves such as, say, sound waves in air cannot be polarized. So here in this diagram or figure, so unpolarized light using a polarizer getting polarized light. So transverse wave can be polarized, longitudinal waves cannot be polarized. Moving to question number 12, calculate the energy in electron volt associated with a photon of ruby laser radiation of wavelength 589 nanometer. So to calculate the energy of photon, we use the relation E equal to hc by lambda, where h is the Planck's constant, E is the energy of the photon, c is the velocity of the light, and lambda is the wavelength. In this problem, lambda is given, which is 589 nanometer. You can say 589 into 10 raised to minus 9 meter. C is the velocity of light. You have to remember this value. It is a constant quantity, 3 into 10 raised to 8 meter per second. And h is Planck's constant, which is 6.6 into 10 raised to minus 34 joule second in the side. So if I use these values and substitute in the formula, we can calculate the energy in SI unit, which is in joule, roughly 3.37 10 raised to minus joule. But the question says that you have to express this energy in electron volt. So to convert the joule into electron volt, we divide it by 1.6 into 10 raised to minus 19. And we get roughly 2.10 EV. So the energy value in EV is 2.10. Thank you for your attention. We come to the conclusion.